Solving right angled triangles. Solving right angled triangles. So this is where we are now. We want to learn how to solve right angled triangles. What's the meaning of solve? When you hear the word solve, what does it mean? Solve. When you hear the word solve in mathematics, what it means is to what? Is to determine the unknown. When you hear the word solve, to solve it means to find the unknown. That means there is something we don't know. So we want to go and know it. So anytime you hear solve something, that means go and determine that particular value that we don't know. Do you understand that? If you understand that, that's what it means to solve. Now, when we now say solving right angle triangle, I believe by now also we all know what's a right angle triangle. We all know what is a right angle triangle. A right angle triangle is a triangle with what? With 90 degrees, right? Good. And remember, I told you that these other two angles here are acute angles, right? They are less than 90. So the two of them will be 90. Do you remember I said that? Although we don't know them, but we know that we don't know that both of them are less than 90, right? So if this one is already 90, that means the other two will be what? We share the remaining 90 that is left. Do you remember I said that? Good. Good. So now this angle here, we already know it. Is that right? We already know that angle. What is that angle there? It's 90. We already know it. Do you get that? We already know that angle. But this angle and this angle, we don't know them. We know it will be less than 90, but we don't know. Are we getting that? But we already know this particular one. So now we need to know them. And that's what it means to find the unknown. We need to what? Know that we need to know what this angle is. Let's call this angle X and let's call this angle Y. We need to know what that angle is. Are we together? We don't know it. That's why we wrote X and Y. So how do we know those angles? How do we determine what those angles are? So what we use to determine those unknown angles is what we call the trigonometry ratio. Everybody write it down. The what? The trigonometry ratio. The trigonometry ratio. Okay, that's what we use to determine the what? The unknown angles. We don't know the angles. So to determine the unknown angles, we use what we call the trigonometry ratio. No, not even ratios. Okay, because there are three of them. We use the trigonometry ratios. So what are the trigonometry ratios? Number one, we have the sine theta. Okay, sine theta. Sine theta is opposite over hypotenuse. Okay, the second one we use is what? Cos theta. Cos theta is what? Adjacent over hypotenuse. Okay, then the last one we use is what? Tan theta. Okay, tan theta is what? Opposite over what? Over adjacent. Adjacent. Let me write it very well. Okay, sin theta is opposite over hypotenuse. Cos theta is adjacent over hypotenuse. And tan theta is what? Opposite over adjacent. So these are the three trigonometry ratios that we use to determine what is our unknown angles and we find it. So now, what is opposite? What is hypotenuse? What is adjacent? What are those three things? Of course, we know what theta is, right? Theta is the angle we are looking for. We don't know the angle. So the angle we are looking for is theta. You understand that now? Is either this, sorry. Okay, we already know this angle, right? 90, everybody knows that one. So we are looking for either this or this. So that's theta. So what is opposite? What is hypotenuse? What is adjacent? Those three words, opposite, hypotenuse, those are the sides of your right angle triangle. They are your sides, the three sides. So how do we know the hypotenuse? The hypotenuse, everybody write it down, your notes right now, write it down. The hypotenuse is the side that is facing the 90 degrees. The hypotenuse is the side that is facing the 90 degrees. Let me show you that. Where's the 90 degrees? This is the 90 degrees, right? So which side is facing the 90 degrees? That's it. That's the hypotenuse. The side that is what? Facing the what? The 90 degrees. That's what we call the hypotenuse. Some people may say the the hypotenuse is the longest side. Well, that's correct, but you can't easily know the longest side now from here. So the easiest way you can know your hypotenuse is to look for that your 90, that your right angle, that the right angle, and look for the side that is opposite to it, that is facing your 90. That is your hypotenuse. So now what is your opposite? And what is your adjacent? Now, opposite and adjacent are not fixed. I'll take that again. Pay attention. Your opposite and adjacent are not fixed. They change. Unlike your hypotenuse is fixed. Once you know your hypotenuse, that's your hypotenuse. It doesn't change. It's always your hypotenuse. Your hypotenuse will always be your what? Your hypotenuse. The side that is facing the what? The 90 degrees. But your opposite and your adjacent can change. So we need to learn how to know the opposite and how to know the adjacent. Are we together? So to know the opposite, the first thing you need to consider is the angle we are looking for. What do I mean by that? Remember, there are two angles that we don't know, right? We don't know this angle and we don't know this angle. Remember, two angles. So we can't be looking for the two at the same time. So we are either looking for this one or we are looking for this one. Do you understand that? We can't be looking for the two angles at the same time. So we are either looking for one or the other one. So now, let's imagine we are looking for this one. For example, we are looking for this angle here. Let's imagine we are looking for that angle, that's theta. If that's the angle we are looking for, then your opposite will be the side that is opposite to the angle that we are looking for. So this will be your opposite. Do you understand that? How did I know the opposite? The opposite is the side that is opposite to the angle that you're looking for. So this is the angle we are looking for, right? So that's the side that is opposite to it. Can you see that? That is opposite. That is opposite. What is hypotenuse? Hypotenuse is the side that is what? Opposite or facing the 90. The 90. I guess that's the 90. That's hypotenuse. Do we get that? Meanwhile, your opposite is the side that is opposite to the what? To the angle we are looking for. Are we looking for a hand? So that means, for example, in another question, if you are looking for this angle, let me put y. If you're looking for that angle in another question, okay, that means this place will be the opposite. How did I know? Because in this new question now, this is the angle we are looking for. Are you getting that? So because you're looking for this angle here, this will be the what? The opposite. Because like I told you before, your opposite changes. Your opposite changes. Are you getting that now? So what determines your opposite? Before you can know your opposite, first of all, you have to consider the angle you are looking for. It is after you know the angle you are looking for that you can now know the opposite, because the opposite is now the side that is facing the angle you are looking for. You may not understand. Now, for you to understand better, let us try a question. Okay? So imagine this example. Imagine you have a right angle triangle. If here is 6 and here is what? 3. Sorry. Here is 3. Okay. And we have to look for this angle here. So we are looking for theta, right? So what were we giving? We were giving two sides. So we are giving the hypotenuse. Am I correct? This is the hypotenuse. That's what's the hypotenuse again? The side that is facing your 90 degrees. That is your hypotenuse. Good. And what are we giving again? We are giving the opposite, right? How did I know? This is the angle we are looking for. Is that correct? So that's the opposite. So we are giving hypotenuse and opposite. So which one am I going to use? Is it sine theta, cos theta, or tan theta? I can't use the three at the same time. So it is the size that they give me that determines what I will use. So is that I use sine theta, cos theta, or tan. So for this particular question now, I'll be using sine theta. Why? Because sine theta is opposite over what? Hypotenuse. I get that? And we were given the opposite and the what? And the hypotenuse. If I use cos theta is adjacent over hypotenuse. But we don't know the adjacent. So you can't use cos theta because we don't know the adjacent. We only know the opposite, which is 3, and the hypotenuse, which is what? 6. We don't know the adjacent. And I can't use tan theta because tan theta is opposite over adjacent. And I don't know the adjacent too. So the only one that I know is that I can use is sine theta because sine theta is opposite over what? Over hypotenuse. And we know that too. So we use sine theta. Are you getting that now? So from here, sine theta, because what is opposite? 3. What is adjacent? 6. Sorry, hypotenuse 6. So from here, sine theta is equal to what? 0.5, right? 0.5. So we are looking for theta, no, not sine theta. So from here, what will be theta? Theta will be what? Sine inverse of 0.5, right? So theta will be what? What is the sine inverse of 0.5? Press your calculator, go to your calculator, press shift sine. So that's the sine inverse. That's 30 degrees. So the angle is what? 30 degrees. Do you get that? The angle is what? 30 degrees. That's the unknown angle there. Okay, so imagine we have another question. Okay, imagine you have this question. You are given here as 10, and you are given here as what? As 5. And you are told to look for theta. And you are told to look for theta. Now, what would be theta here? First thing first, are we going to use what were we given? First of all, what were we given? So were we giving hypotenuse? Were we giving opposite? Were we giving what? Adjacent. So let's see. This is the 90, Abby. That's the 90. Do you remember? So what did I tell you is the hypotenuse? Hypotenuse is the side that is facing the 90. Is that correct? So this, first of all, that's the hypotenuse. Because I told you your right angle triangle can be drawn in any way. You can draw your right angle triangle in any way. But the most important thing is your what? This your 90. Once it's there, that's a right angle triangle. It does not have to be like this all the time. Do you understand? It doesn't have to be like that all the time. It can be in any form. So the most important thing is to look for if this particular right angle is there, that means it's a right angle triangle. I guess that. So the side that is opposite to that angle is your hypotenuse. So this is the hypotenuse, that's 10. So we are given another one 5. So what is 5? So from here we can see that this is the angle we are looking for, right? This is the angle we are looking for. So this is the side that is opposite to the angle. So that means your 5 is opposite. You understand? Your 5 is what? Opposite. Can we see that? Your 5 is opposite. So from here, we will say, so that means we are giving opposite and what? We are giving opposite and hypotenuse. So we're using sine theta. Okay, so sine theta will equal to opposite. What is opposite? 5, right? 5 over what is hypotenuse? 10. Are you know opposite of hypotenuse? So sine theta will be equal to 0.5. Okay. So what is theta? Theta will be what? Sine inverse of what? 0.5. Is that correct? So theta will be what? 30 degrees. Do we get that now? Okay. Two more examples. Two more examples. So imagine you are given this triangle. Okay. And if here is 8 and here is 4, I have to look for theta. Are we together? We are looking for theta. Okay. We are looking for that angle there. We don't know it. So we want to know it. So how will you get it? So first of all, what side were we giving? Of course, we were giving your what? Hypotenuse, right? How do we know the hypotenuse? The side that is facing the what? The 90 degrees. Is that okay? Then what we're giving again? Opposite or adjacent. Now this time, we are giving what? Adjacent, not opposite. How do I know it's adjacent? Because this is the side facing the angle we are looking for. So this is the opposite. I get that. That's the side that is opposite to this. I told you it changes. You know the first question, the question one. I go and check question one. If you check our example one, if you check example one, this side was the opposite for example one. That was the opposite. I mean, but why was the opposite? Because the angle we were looking for was here. So here was the opposite. But this time now, it is no longer the opposite. I told you they change. It's not fixed. They change. The only way you can know them is through what? Is that you will look at the angle you are looking for. So this is opposite. So here is the what? Adjacent. Do you see that now? Good. That's the adjacent there. So adjacent and so what are we using? That would be cos. We'll be using cos. Cos theta is equal to what? Adjacent over hypotenuse. Do you get that now? Adjacent. So this time we're using cos because we're giving adjacent and hypotenuse. So cos theta will be equal to 4 over 8. So cos theta will be equal to what? 0 point what? 0.5, right? So theta will be cos inverse of 0 point, sorry, 0.5, right? So theta will be equal to what? 60 degrees. So that's your theta. Okay. That's the angle we are looking for there. It is 60 degrees. Do you get that? The angle we are looking for there is 60 degrees. So to the final example of the night. So imagine you are given this question. Okay. Are we together? Imagine you're given that question. Okay. If here is 3 and here is 4, and we are supposed to look for this angle. Okay. We are looking for that angle now. We don't know it. So how do we know that angle here? So first of all, what were we given? We were given, so this is the hypotenuse, right? Remember, hypotenuse is the side that is facing your 90 degrees. So we are not given hypotenuse, can you see? So there's no hypotenuse in this question. So that means we're either giving opposite and adjacent. So which one is the opposite? Which one is the adjacent? Is 3 the opposite? Is 4 the adjacent? So this is the angle we are looking for, right? So that's the side that is opposite to the angle we are looking for. So that's the opposite. So don't forget, the opposite is the side that is opposite to the angle we are looking for. So 3 is the opposite. That means 4 is the what? Is the adjacent. So opposite and adjacent. That is what? Tan. That is for tan. So tan theta is equal to opposite over what? Adjacent. So there's no hypotenuse in this one. We're not given hypotenuse. So opposite and adjacent. Are we together? So what is opposite? Opposite is equal to, that's 3, right? The side that is opposite to the angle we are looking for. So that's the opposite over 4. Are we together? Good. So what is 3 over 4? So tan theta is equal to 0.75. So that means theta is equal to tan inverse of 0.75, right? So that means theta will give you what? That's the tan inverse of 0.75. Okay, how would that be? Let me see. That will give us 30, 37 degrees. Is that okay? So this is how to solve right angle triangles using the trigonometry ratios. We use either your sin theta, your cos theta, or your tan theta, depending on the sides you are given. So in your triangle, if you check a triangle, if you are given the opposite and the hypotenuse, you use sin theta. If you are given the adjacent and the hypotenuse, you use the cos theta. And if you are given the opposite and the adjacent, you use the tan theta. So to know your hypotenuse is the side that is facing your right angle, that is facing your 90 degrees. The opposite is the side that is opposite to the angle you are looking for. Abi, you understand now? Facing the angle you are looking for, and your adjacent is the last side after you know your hypotenuse and your opposite. All right. I'm sure you've learned. So your assignment to be sent to your DM. Please, today. It's good to have you today. See you next class.